Good morning, class. So today we're going to talk about the conservation of energy and particularly how it is conserved using potential and kinetic energy. So if I go to our class notes, we know that the conservation energy basically is saying that we can't either create some energy or destroy it. The energy that we have in the universe is constant, that it's basically just changing from one form to another. And there isn't any net loss or gain. For example, you burn gasoline in your car, that is stored potential energy, chemical stored potential energy. It is changed into mechanical energy with the movement of your car. We also have sound energy. We have heat that's made by the pistons sliding past each other, the engine working, the fan belt. All of those things are transfer of energy, of that potential energy in the gasoline, changing forms to another. So it remains constant throughout the system. There are two types of energy that we want to talk about. We can just kind of split it up into two general types: is mechanical energy and non-mechanical energy. And in here, of course, we are more concerned about the mechanical energy. So if we look at the formula that we can get from this, is that the mechanical energy is equal to any of the change in the kinetic energy or any of the potential energy in the situation at the point of frame that we are looking at. So we can break that down saying that the mechanical energy initial is equal to the mechanical energy final. So we can break that down even more and break it into this. And I want to change screens quick. So if we look at this, we can take our mechanical energy, and we know it's equal to the combination of whatever kinetic energy is in the system and the potential. So we can break that down into even farther into the initial, and the initial of the two types is equal to the final. So if we go to page 172, number 2, I want to work through that problem with you quick in our homework. So why don't you open up your books, get that, pause the video if you need to, and I want you to be able to read through the given and give you a little hint on these problems. We can break it up even more. In this problem, you're going to want to keep track of the initial height, the initial kinetic energy, the initial potential. We can do the problem at midpoint is what they want to know, and they equal to the final of each one of these. And we're going to break this problem up and do it from this point to this point, and then from this point to this point to get all the answers that we're looking for. So why don't you pause the video, see if you can get the given set up, and we'll move on from there. Okay. So hopefully you have the given set up, and we should have this information. We know the initial height, and we know that there's no movement. It's static at that point. So the initial energy of the kinetic is 0. It's only at the midpoint that we have both situations. We have movement and we still have potential energy that we can gain. At the end, we have no height, which immediately lets me know that I have no potential energy that can occur there. So now if I continue on the problem, I know I can set up my equation like this. So I can do it any point along the line. I can figure out the mechanical energy I have. And then I can jump up here and say, oh, the kinetic energy is 0. So I'm going to get rid of that equation. Here I have everything. So now notice that the mass is the same all the way through. So I'm going to get rid of it. Let's just get rid of all the mass. Then I got my velocity to itself over here, took everything times 2, and I have this. But notice that this problem even gets simpler if I do that. I take out the 2g on both, and it's just equal to the change in height. That's all it is. So I put my values in, make sure you take the square root of it, and I get my velocity at the midpoint is going to be 9.9 meters per second. So now let's look at the final. The final, my mechanical energy of what I begin is also equal to final. I could have started from the midpoint. I could have said right here, I could have started from the midpoint to here. The reason I didn't, because I want to be able to use this 0 to my advantage and have less variables that I have to worry about. You could have gotten the correct answer by going from the midpoint to the final. But again, I want to use anything with a 0 to simplify my problems. And I can get rid of 2 things right away because of that. So now substituting in my formulas that I have this. Notice mass is the same. I'm going to get rid of that. Now I have my final velocity is just equal to this. Put my values in, take the square root, and it should make sense that it's also faster at the bottom of the hill. So I know that my values have got to be in the ballpark. All right, so you have just a little bit of homework left to do. You have a few problems that you need to finish off that you should be able to do. Number 3 and number 1, and then also 5B, you have a few problems to do. Again, if you have any questions, please email me or jump into our Zoom.